With this particular question, it says in the diagram below, points R, P, and A, right? There's R here. See here, R here, P here, A here, and then you have Q here. These points, right? And then they lie on the circle. Then they said RA bisects R. No, RA bisects R. Oh yeah, the line here. When they say bisect, it means that it's cutting in half, exactly in half, meaning this angle here is exactly equal to that one. Now, before we even carry on, R2 is going to be equal to Q2 because the angles in the same segment.
Yeah.
Yeah. And then P is equal to A. Also angles in the same segment. I mean, just for the sake of what we're doing, I mean, let me remove these blue dots because they're just making the sketch a bit too messy. But other dots we can add here. We'll add based on the information we're reading. Then they said here AB is equal to AQ. So these are equal because of base angle of the isosceles triangle, right?
Yeah.
Yeah. And then what else now? RA and TQ. There's RA here. And then there's TQ there. They said both of these lines they meet at B. So for 1 mark, for 3 marks, right? They want us to prove that AQ bisects PQB. So all we have to do is to prove that the yellow dots are equal to the blue ones here. Because if you're gonna say that AQ bisects this angle, it means that you just have to show that the angle there is equal to the angle there. So remember, our job is we always say that we should focus more on individual angles that are equal to the ones we're working with, which is okay. But the only thing is with this particular question, the one thing that stands out is, fortunately, as you said, we have a cyclic quadrilateral. So we should not forget the fact that we have an exterior angle here where they are talking about what they're talking about. This exterior angle, fortunately, we know it's equal to this one. You see?
Yeah.
Yeah. And then what we also then now know is that part of this angle is Q2. And then part of this angle is R2. So if they each have a portion that's equal to each other, it means the other portion has to be equal because the full thing is equal to each other. Do you get it?
Yes, I do get it.
Yeah. So that's what we need to tell them. We need to tell them that the whole of angle R is equal to PQB, right? The reason is exterior angle of a triangle.
Yeah.
No, cyclic quad. I meant cyclic quad. Yeah, there you go.
Yeah.
So from here, this is one, right? The second thing is you're gonna state here Q2 is equal to R2. The reason for that is angles in the same segment. There you go. And then now that you've shown that Q2 is equal to R2, you can then say, therefore, Q3 is equal to what you may call R2, R1. It's more of a conclusion, right? But So if we're proving that Q3 is equal to R1, right? And we've proven that Q2 is equal to R2. All we have to do is we need to tell them that these are equal to each other because it is given. They told us they're equal. So if these two are both equal to the same two angles, it means that they're equal to each other. You see?
Yeah.
Yeah. So here we're saying R1 is equal to R2. The reason is given. They told us because they told us in the beginning that this line here bisects R. So because we have shown that they are both equal to R1 and R2, we can say therefore Q2 is equal to Q3. It's a conclusion. And then here we can say therefore AQ by sec P Q B. There you go. That's the way
Mhm.
I like. That's the way we like it. Yes. So this is 8.2, right?
Yes.
Yeah, they said here TR is equal to TB. We should prove that TR is equal to TB. Let's prove that this line is equal to this line. No?
And the RT.
Yeah, it's equal to this big one here.
Yeah.
Fortunately, that's an isosceles triangle, right?
Yes.
Because
We need to prove that. So,
yeah, and we can do that by just showing that this angle is equal to that one. You see?
Okay.
Yeah.
Yeah. See.
Yeah, which is why, again, analyzing the sketch in the beginning, these are the things that show that analyzing the sketch in the beginning is priceless. Because in the
Yeah.
beginning, we had gotten everything we are talking about now. See, so one thing we are saying now is that B is equal to Q3. The reason is angles opposite equal side. So Q3, fortunately, we know it is equal to Q3. We can actually just say it is equal to R1 because of an exterior angle of a cyclic quadrilateral. Because you see, RAQT is a cyclic quad. You see?
Yes.
Yeah. So we can even use that law. Q3 with R1 cyclic quad. No, exterior angle of cyclic quad. Oh, yeah. Exterior, right here. Exterior angle of cyclic quad. And then, since we have now said that this is equal to this, and we have said that this is also equal to that, it means that since they're both equal to the same thing, you see Q3 is equal to R1, Q3 is equal to P. It means that therefore, as a conclusion, P is equal to R1. Since these are equal, right, we can say therefore, TR
equals TV.
equal to TB. The reason is sides opposite equal angles. Like that.
Yeah.
Yeah. So 8.3. Yeah. So we're left with this 3-mark question here. This 3-mark question is asking us to prove that P is equal to TRP. No, P is equal to TRP. So TRP, let's see, P here is equal to TRP. Okay, let me try that again. T, which is this pink one. We should prove that it is equal to TRP. This big one here. Now let's make it in red because we already mentioned that that one is in red. Yeah, so this P we should prove that it is equal to this R here. So fortunately, we already know that this R that they're talking about is equal to that one. So if this here is going to be equal to that, do you see that it also shows that we're dealing with parallel lines?
Oh, how does it show that we deal with parallel lines?
Because firstly, if they want us to prove that these are equal to each other, what we already know is that this one that they are talking about is equal to this one here,
Yeah.
right? Yeah. So if these are equal, but they are also asking us to prove that these are equal, automatically in our minds we should see that, okay, if this one is definitely then going to be equal to that one, it means that these are parallel lines, because the angles that we're dealing with here, these are alternating angles.
Okay, I see the alternate angle. Yeah.
So if these alternating angles are equal to each other, it means we're dealing with parallel lines. So once we have identified that, you can think to yourself, okay, fine, let's maybe show that these are parallel lines using another way. Because if you can show that these are parallel lines, we'll then be able to say that this angle is equal to that one, because we'll then be able to just say alternating angles after we have proven that they are parallel. So proving that they are parallel, fortunately, the other side of the sketch has another set of alternating angles, which is the yellow. You see, R2 here is equal to this here. We need to tell them we know that. So the way we're going to tell them that this R2 is equal to this angle here is we're going to link it to R1. Remember, everything that you do in your exam, everything that you do on your answer sheet, it all works together. So you have already shown that B is equal to Q3, and you've already shown that Q3 is equal to R1. You've already shown that all these three angles are equal. 1, 2, 3, 4, 5. You've already done all that. So without you overly complicating anything, all you need to do is you need to lay down that information. See, you can just say here B, right, is equal to R2, R2, or rather, you can just say B is equal to R1, which is equal to R2. All this has been proven, right? Because
Yeah.
B1 is equal to this, or you can even do it as a chain so that your work is traced. You see, B, you said it's equal to Q3, right? Q3
Yeah.
is equal to R1. R1 is equal to R2 from up here, or it's a given statement, right?
Hmm.
Yeah. So all this has been proven. B is equal to R2. That's been proven. So now you can say, therefore, the line here, RP, is parallel to TP. You see?
Yeah.
So yeah, the reason is for that is alternating
And
angles are equal. Alternating angles are equal. Because remember, alternating angles, it's all about a zigzag effect. But the moment they are equal, they are lines that have parallel lines somewhere. But anyways, with that being said here, we can say R, we can now say the question that they're asking us here, the T R P. We can tell them that this angle is equal to that one, right? And then we can tell them that this one is also equal to that one. So because they are equal to the same thing, it means that they have to be equal to each other. You see,
yeah.
that's what we're then gonna say here. So here, let's say the P is equal to this one because they're alternating angles. P is equal to angle PQB. The reason is alternating angles. And then you're going to say R is equal to the same PQB, because exterior angle of a triangle.
Yeah.
Exterior. And then you can say therefore the P here go to the R here. That's now what? Yeah, it's basically, what can I say? You've now proved what they wanted us to. Is it? Yeah, the P here is equal to the R there. That's basically what this is, right? T R P, and then there's P. But here we can maybe write it as TRP, which is what they want us to do.
Yeah.
TRP, TRP.
TR.
There you go.
Okay.
Yep,
That makes sense.
I think so.
Awesome.
It is all good. It is all good. It is all good.
Yeah. Thank